Alright, so number 8, implement the function str. The function takes two strings as arguments, s and x, and looks for the occurrence of the string x and the string s. The function returns an integer denoting the first occurrence of the string x. So here are my examples. We have s and then x, and then we're taking our string of x and looking for the substring within s. And if I just visually look at it, I can see there's just one y here, and if I go back, we can see that this last block here in the string matches up with this. And so the simplistic way to do this would be to just look for all the substrings within s that are of equal length to x and find the one that matches. And so you would have like 2 pointers and then match up one by one, and then once you would get to a mismatch, you would bring I down and start all over again. But that is a lot more work than what needs to happen. So the logic for what we're going to be doing is, say I was matching these up and then I got to D and X and saw that there was a mismatch. I would be constructing an array to find all reoccurring characters that occur within the substring, and we would basically be looking for any suffix that matches the prefix within this substring within this. And so in this case, we would have matched up to here, and then I would know that, from this, that this equals to this, and since we don't have an A reoccurring within here, we don't necessarily need, I would be here at this point, and then we wouldn't necessarily need to go backwards because we would already know that we're not going to find another A past this, so we would just start back from here to match again. And we see A and X don't match, so take I down, and then we would have it matching from A to A, B to B, C to C, D to D, A to A, B to B, C to C, and then we would have D and Y, so it would stop. We would be matching all the way up to here. Let's see. And then we would see within here that we have ABC here, and that matches, we have a suffix here that matches our prefix. So we would know from here that we have this last part is matching up with the prefix in our substring. So we would just take our pointer back to this D, since we don't need to go through back and do the work of matching this up, since we know we already can find it here. So we would just start at D, and then we would start back here and then start matching again, and then we would have D, D, A, B, B, C, C, Y, and then we would find that substring that matches. And then that takes a lot less work than going back through and looking through every single iteration that can occur. Alright, so I have my example strings here. I have S, this long string here, and then we have X, and we're gonna take X and see if we can find it within our string here. So for the first part of this problem, I have the code here for us to set up a temporary array so that we can find any common suffixes amongst our prefix. So I'll do that, and so we'll have initialize LPS to be the length of X. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright, and then we'll initialize j to be 0. And then we'll be having a for loop for I that will start at 1. Alright, so now we're going to be comparing I to j. And this first one should just be 0. Oh, and then I gotta write. Alright, so I is at B and j is at A. So those don't match up. So we'll look here. Else j is equal to 0. So we'll come to this last condition, and LPS at I will equal to 0, and then we'll increase I. So we'll put 0 here, and then increase to I. And now C does not equal A, and J is still at 0, so we're just going to add a 0 here, and then increase I. Now D does not match A, and J is still at 0, so we're just going to add 0, then increase I. And here we have A does equal to A, so if x at I equals to x at j, LPS at I equals j plus 1. So j is at 0 plus 1 is 1. And then we iterate both j and I in this case. Alright, now B matches up with B, so we take j as at 1 plus 1 is 2. And then we move each one down. Alright, C matches up with C, so j is at 2 plus 1 is 3. And we'll move each one down. Alright, so now Y does not match up with D, and J is no longer at 0, so we'll come to this condition. If J is not at 0, J equals LPS at J minus 1, so J is at 3, 3 minus 1 is 2. LPS at 2 is 0, so we move J back to 0. And now we compare again. Y does not equal A. J is back at 0, so all we do is add a 0 here. And then now we've gone past, and so this is the table that we get. And so we can see what this represents if we are matching, or if the match is ending at any of these points here. So if we end at like here, then we would have this equaling to our prefix at a value of 3. If it were to stop here, then we would just have a value of 2. And then stopping at any of these zeros, we wouldn't have any suffixes and prefixes matching up. Alright, so for this, we're going to set I to 0 for S, and then J to 0 for X. And so we'll just be starting out comparing I to J. And so in this case, Y at I equals X at J, so we're just going to move each one down. Now B and B match, so we'll just move down again. And C and C. Now X and D don't match, so I'm gonna come here. J is not at 0, so we'll ignore that. So else, oh yeah, J is not at 0, so J equals LPS J minus 1. So J is 3 minus 1 is 2, so we move J back to 0. Yeah, because we don't have any, we have all unique characters, so we just start J back over again. And so now J at A again does not match up with I at X, so all we're going to do is move I down. Because we have effectively kind of matched up all of this previously, so we don't really need to start I back over again. We're just going to move forward. So now J and I are equal, so we'll move these down. J and I match up again. And then C and C matches. D and D match. A and A match. B and B match. C and C match. Alright, so now Y and D don't match. And J is not at 0, so J equals LPS at J minus 1. So J is at 7. 7 minus 1 is 6, so LPS at 6 is 3. So we move J down to 3. And you can see, because what we have here, we have this and this. And so we don't need to we don't need to match up this again because what we have behind us is already matching up. So we're going to start J at D here. And so J and I are both D and they match, so we'll move down. I and J match, we'll move down. I and B match, so we'll move down. I and J match at C, so we'll move down. And then Y and Y match, so we move down. So now J is at the length of X, so we come down here. If J equals X length, return I minus X length. So we have I is at 16. 16 minus 8 equals 8. And then at index 8 is where the start of this X occurs in our S substring. And so then the time complexity to create this is O of M, and that's going to equal to our X. So we're just going down the length of X, and then the time complexity for this part is O of N representing this S substring. So the total time equals O of M plus N. And then the additional auxiliary space that we use for this would be O of M.